Hello and welcome to our ethics project. Abby, Jenny, and myself worked on this, and we are answering the question, should you disclose the bridge fault to the public? We are creating a neural network to answer this question. Also, for clarification, before moving forward, we are answering the question if they should disclose it to the public, not if this information should be disclosed to the public. All of these questions hold weight, but there was an order to which ones we looked at, and some questions had more weight than others. The red questions are the ones that we looked at first. They hold the most weight to us. The green questions are the ones that we looked at next after the red questions. The underlined questions are the ones that we looked at after the green questions.
As you can see here, we randomly generated inputs that were then analyzed to determine if in each given scenario, the individual should or should not disclose the bridge faultiness to the public or not. Here, you can see that the majority of our inputs were binary, with few exceptions. For example, question 6 is the year in which the bridge was built, and question 7 is the state that the bridge is in.
MATLAB has 4 kinds of neural networks: pattern recognition, fitting, classification, and time series. Pattern recognition is the process of classifying input data into objects or classes based on key features. There are 2 kinds of pattern recognition: supervised classification and unsupervised classification. Ours is using unsupervised classification, which works by finding hidden structures in unlabeled data using segmentation or clustering techniques, such as k-means clustering, Gaussian mixture models, or hidden Markov models. The fitting neural network in MATLAB uses the default training algorithm of Levenberg-Marcotte, but you can change the training algorithm to whatever method you feel would fit your data better. You can use Bayesian regularization or gradient descent, among many other training algorithms. The classification neural network in MATLAB solves a clustering problem using a self-organizing map. It involves grouping data by similarity. The time series neural network in MATLAB can be used to solve 3 different kinds of time series problems. You can predict future values of a time series from past values of that time series and past values from a second time series. You can predict future values of a time series using only the past values from that time series. Or you can predict the values of the second time series using the first time series without having previous knowledge of the second time series. Our neural network uses pattern recognition. The input data is a 90 by 26 matrix, which is 90 scenarios that we've created, and the target or output data is a 90 by 1 matrix, which is the 90 outcomes that we have determined as a group as to whether they should inform the public or not. 1 means that they should inform the public, while the 0 means they should not inform the public. Here is how our function works. First, the matrix is inputted. Next, the function initializes the constants, which include the input parameters and the neural network layers, the weights and biases. The input parameters are the input offset values, the gain values, and the minimum values. Next, it runs the neural network simulation. It sets q equal to the number of scenarios to be evaluated and x1 as its transpose. It applies the map minimum and maximum processing function to input and assigned transformed values to xp1. Next, the logsig function is applied to the transformed data in xp1 and assigns n1. Next, the tansig function is applied to the transformed data in a1 and assigns a2. It sets the transformed data in a2 to y1 and assigns y1 to the transpose of itself. Lastly, it outputs y1. And now a live demonstration.
As you can see, by using the pattern recognition tool in MATLAB, we are able to accurately determine whether the engineer should or should not disclose the faultiness to the public. A confusion matrix is a summary of prediction results on a classification problem. The number of correct and incorrect predictions are summarized with count values and broken down by each class. This being said, you can see here that our confusion matrix shows us that the test set is predicted correctly 80% of the time, which means the neural network is significantly reliable.